The Commodore VIC-20. The original bread bin from the chicken lip manufacturer. I am very proud to have this near mint condition example of one in my collection, but I am somewhat sorry to say that out of all the machines I own, this one probably gets the least use. And that's because I don't really have any means of loading software on this. Now, okay, I do own an SD to IEC for the Commodore 64, and that will work fine on the VIC-20. But one limiting factor of this machine is the RAM. There's only 5K of it installed in here, and by the time BASIC comes up, well, you're left with just over 3K available. So you can appreciate that limits the sort of software that you can run. Most people will have fitted a memory expansion to the cartridge port on the back of the machine, and up until now, that's something I didn't have. Over on the CRG Discord, links in the description, and everyone is more than welcome, by the way, but over there, user Foxhoria, well, they've put together what you could possibly describe as the final expansion you would ever need for a VIC-20. Yeah, you could describe it like that because that's exactly what it's called. The final expansion 3. They put together one of those. That gives you a RAM expansion, an SD to IEC on board, and it's also a cartridge emulator with a ROM on there that you can flash. So absolutely ticks all the boxes. I reached out to Foxhoria to see if by chance they had any kits left over, and yes, they did. So in this box, we have 2 such kits. Why did I buy 2 of them? Well, that's because I want one for me, and the other one is going to go with another VIC-20, which I am currently in the process of refurbishing. That is going to charity auction on the 12th of October, ending on the 19th of October. And that is for the charity event being run by Lee from More Fun Making It. All proceeds will be going to the befriending scheme. So I need to have that machine and all the accessories that's going with it ready for the 12th for the auction. It is currently the 4th of October, so I am running out of time. We have lots of parts inside this box. There's lots to do on this PCB, so let's get stuck in. So we've got the PCB and a big bag of goodies. Hopefully everything that we need is in here. I think it is. But I think what we'll do, just because this is such a tight board, and there are components there that are going to sit within the footprint of other socketed chips. So I think what we'll do is start with those, and in particular we'll start with all the surface mount stuff. So in this little bag we had all of these components. The 2 ICs I can put out of the way, but I think what we'll do is just fit the rest of this, just so that nothing goes missing. There is the extent of the surface mount stuff. Let's get that on. We'll start with the voltage regulator. This component is big enough that I can just orientate it with my fingers, I think. And yeah, let's just use the tweezers. That looks pretty good. Get the other legs down. I've managed just to block 2 holes. Not really off to the best of starts here, are we? But we can very easily unblock them again. 2 little capacitors next. So for these, I'll just load a bit of solder onto the iron. And we'll offer up the cap, and then the solder on the iron will do the job for us. That's one. And that's the other one. Then it's just this IC to finish off the surface mount stuff. You can see the orientation that it needs to go on in the outline of the silk screen. Little notch there on the silk screen, little notch on the chip itself. That is going to go on like that. Now, where do these bits go? Well, positions for LEDs over here, G and R, presumably green and red. And there's a positive side noted there, so these must go in as such. We do have a case for these, and yeah, it does look as if I want to leave those LEDs sitting off the board a little bit. Just not sure how far off the board. I've left them there sitting up off the board about 10mm or so. So let's squidge a bit of blue tack onto that, or well, white tack, but you know what I mean. And that's going to sit in here. That is going to sit on there. And yeah, that's fine. I'll stick up through that case a little bit, but I think that'll look nice. It's always easier to cut another bit off later if we need to, rather than trying to add another bit on. Let's just try that again since there's no blue tack in the way now. Yeah, that's actually perfect. That blue tack must have been holding them up a little bit. So they now actually are flush with the top of that, so they're just sticking through ever so slightly, but that is perfect. Next up is this crystal, 8 MHz, and that must go there. Then there's another little crystal. It would remind you of a clock crystal, and that's another thing this has, actually a real-time clock. So this must be a clock crystal. Where does it go? Over here. Last thing then out of that first bag is this set of 4 switches. They must go on there. It says their device ID 8, 9, 10, 11. So is that what this is used for selecting whatever device this is presented as to the VIC-20? We do of course need to figure out how to use this properly. But one thing at a time. I obviously need to build it all first. So, what's next? How about a lot of resistors and diodes? Those are the next components that are sitting in between those other ICs, so they'll have to go on first before I put said other ICs on. Or well, the sockets for them on. And Foxhoria has very kindly labelled everything for us, so this is nice and simple. Don't think I'm actually going to need to find a bill of materials because all the components are labelled and everything is equally well labelled on the silk screen. There, for example, are 1, 2 and 3. They're all 3.3K. And there are 3 3.3K resistors. Those are really small. I would normally use 1/4 watt resistors for everything. Those might actually be 1/8 of a watt, just because they are so small. I do have some 3K3 1/4 watt resistors. They just fit that footprint a bit better, don't they? And just to annoy all the OCD people watching, I'll only put the last one in the other way around. With the orange and brown stripe to the top that time. No, that would just annoy me as well. It might sound silly, but I always like to have the resistors of the same family all orientated the same way on any board I'm building. It's coming together rightly. All the resistors are on, the diodes are all on, and I fitted that cap. I was just about to fit the cap for here, this one, but then notice the outline of it. So that's making me think there that we need to lay this cap down on its side. I think we need to do that with it. Just all of these caps to do them. 0.1 microfarad or 100 nanofarad. That's how they're marked on the silk screen. 100. Just a few more small components and then it's just sockets. And the rest of those small bits are in here. We've got the SD card slot. There is a battery holder, which goes on there. And then 2 buttons. Red for reset and blue for drive reset. Although this one's black, but close enough. Look what I've done. Oh, honestly, I got a blob of solder on that. That's the name of the board, Final Expansion. If you didn't know any better, you'd think that's the way it was meant to be. These slots are keyed. There's two like wee nipples on the bottom of it. And I'll go down into those holes. I'll do the shell of it first, just so we're happy with the orientation, because there is a bit of movement in it, obviously. And yeah, I think that's okay. So we'll do the other side. And then we'll tackle those pins at the rear. See that there? There's one pin on this that is unused. And there's no pad for it or anything, just an X on the silk screen. Maybe we should have cut that pad off first. Or cut that leg off first. But I suppose it'll be fine sitting there. I mean, it's not going to be any different cut off. Or just hanging there, is it really? It's not like it can move. Ah, I thought those were the same pin, the same signal. They're not. Just as well I noticed that. Like a bit of flux should hopefully sort it out though. Maybe I put too much solder on that. I think I've sorted that now. That's that bridge gone. But we'll just check it here with the meter quickly. Yeah, that's okay. That's sorted. So what is next? We have two ports, two IEC ports, a load of sockets and some jumpers by the look of it. We are going to be fitting one chip though with no socket. This one here, the 74LS245. And that's just because this needs to sit down within the footprint of that other IC. Sockets next. We've got a 40 pin and two 32s. The 40 pin must go here. It doesn't really seem to want to go right down. Ah, that resistor is stopping it. Not 10k. Wonder do I have enough length on those leads that I can bend that a little bit. Just move it left ever so slightly. That should be enough. Yeah. That's that socket in place now. The socket has moved on me slightly there. It's fell out of its holes, so I'll just remelt that solder and push it back through. That's it on that side, but I need to do the same on this other side now. And that, I think, should be it. I'll just check. Yeah, it's sitting flat against the board, so let's get the rest of these done. That socket went on in the same way, but this one though, which needs to go there, well, there's now an IC in the way. We need to remove this central strengthening bar here. Now we could just try snipping it out with these, but you're going to run the risk of cracking the plastic. So what I'm going to do instead is bring out the Dremel. And we will very carefully try and cut through this. And that will go on like that, maybe. Oh, I've bent a pin. That's it now. Just two ports to fit, and I think that's it. Well, other than positions for jumpers, but I'm not actually sure if we need to fit those. And the reason I say that is because they wouldn't be accessible from inside the case. There's the top of the case there. The only thing accessible is that switch block. There's nothing on the side of it, is there? No, nothing on that side there, for example, where those are. So, I don't know if we need to fit them. They might actually only be used for programming, although I'm not sure about that. That is a whole other kettle of fish. We will deal with that in a minute. But the two ports, these are just two serial ports. For the SD to IEC, you need to make a connection from this one to the serial port on the back of the VIC. This one, I assume, would just be a pass-through for your next device. Well, that's it all together. I think in total it took me just under 2 hours to build this, and a very enjoyable build. But the bit we have coming up next, well, that's the bit I never enjoy. This is the bit I always struggle with, because this is programming our ICs, or well, programming a CPLD and the Atmega. These two, they obviously don't need programmed. This Alliance chip, this is 512K of SRAM. And this AMD chip, that is 512K of flash ROM. Now, these two devices here, well, Foxoria included this one with the kits. This is a little breakout board for the CPLD. And thank you very much for including that, because I don't have one, or anything like it for that matter. And he had also told me to go and get one of these. This is the programmer for said CPLD. That will go on there. And this, if I get the orientation correct, this will go in here. And ultimately it will all go in the PC to be programmed. But before we do that, there are a couple of things that we need to do on the computer. So Foxoria very kindly wrote me these instructions, because while programming the Atmega is relatively straightforward, programming this thing, well, me and programming CPLDs, it is never straightforward. So there are various bits of software throughout these instructions here that he tells us to download. I have already downloaded all of that, so let's just run through the instructions and see if we can get this done. First thing I need to do then is convert the CPLD JED file to SVF. So download and install that, which I have done. I've also downloaded the JED file. Let's open software. That is it hiding just there. Then under edit, add new device. Should already be 0, click OK. Make sure the device is ATF1504AS. 1508, nope. 1504AS. Change JTAG instruction to verify write. JTAG instruction, verify write. Well, that's not in there. I wonder, does he mean that? Program verify. Let's go with that one. Then you can press browse to choose the JED file. Right, it's in our assets folder. There it is there. Open. OK. Tick the right SVF file. That. Choose your file name. Click open and then press run. Okay, that seemed relatively straightforward. We can exit that. And there it is. There is our SVF file. So time to program the CPLD. Download and set up Open 0.12.0 and ZADDIG or ZADDIG. Download and set up those two programs, which I think I have done. Trying to find a Windows version of this bit of software was next to near impossible, but well, I downloaded something anyway. And now we need to plug this into the computer. Use that program to change the driver for the USB serial converter to that one. Right. That program is hiding there. Now how do we do this? Because this hasn't picked up any devices. But if we listed all devices there, we are looking for a USB serial converter, that would be that one, and we're looking to change it to that. How can it possibly take up to 5 minutes to install a driver? Right, there we are. I think that's us finished with this bit of software, so I'll close that again. So copy, move the OpenOCD scripts folder into the OpenOCD bin folder. Okay, there is the OpenOCD folder. Looks like I've downloaded the wrong thing, because that looks like a Linux distribution. Right, one quick hiccup later, and I think this is what we need. So where was I in this? Copy move the OpenOCD scripts folder into the bin folder. OpenOCD scripts. Let's copy that into the bin folder. And then open a command prompt in the OpenOCD bin folder. There we are. Use this command and take note of whether the file name you choose has whatever. So basically use that command and replace the file name there with the file name that I selected. So that command, I would imagine I need to put that SVF file. We're going to have to put that into this bin directory as well, because that's where we're running things. Should be it. So let's hit return. And I found the device, but I don't think it actually did anything. Ah, that's what's wrong. I didn't call it, oh here, I can't do that. I didn't call it VIC20 final, I just called it VIC final. And that looks to have programmed successfully with 0 errors. That is what we were looking for, with no errors. And that is it now done. So it's just a matter now of taking that out of there and putting it in there. We'll use the PLCC chip extractor. And again, paying attention to orientation. Pin 1 is to the left. That goes in like that. Let's do the Atmega next. That is a bit more straightforward because we can just use the TL866. So programming the Atmega. Download the hex file, which I have already done. Open XG Pro and select our chip. It is an Atmega 1284 40-pin DIP. Then we need to load our file, which is that one. Did that load anything? It didn't load an awful lot, sure it didn't. There's just a little bit of data there, down at the bottom of that. But other than that, that chip is blank. We then need to go to the Configure tab and set the fuses. So the fused low byte only has SUT 0 equals 0 ticked. It's just that one, so change all of those. The fuse high byte, oh no, the other way around. Fuse high byte, those three all off, rest on. Extended fuse byte, we want level 1, and then nothing else needs changed, and we can now program. This one goes there. Why is that not going in? Because that's stopping it. Just folded that over there as far as it will go. It's resting on top of that 10k resistor there. But that at least allows the chip to go in now. I was just about to stick this into my VIC20, but then I thought maybe we should actually put this in its case first. Just on the off chance something on the bottom of this, one of those pins there, where we touch something in here and short something out. Don't want to damage this, don't want to damage this. So this goes into the case like so. I do have a little bag of screws here. And oh yes, these things. I remember Foxoria was telling me about these. What we need to do is put this into here, but we need to melt it into there and heat it up so that we can push it down into the plastic. Can I push that down in there now? It'll obviously take a second to transfer the heat into that nut. Yeah, there it goes. And there's a little bit of movement in that, but that's fine. It's not going anywhere. We'll put the SD card back in. Let's get it in the VIC20 and let's test it. Well, I knew it was all going far too easy because it turned into a nightmare. As you can see, the final expansion 3s have doubled. I decided to go ahead and build the other one. Did anyone pick out the 2 mistakes I made when assembling this one? I put that capacitor in back to front and I mixed up the positions of those 2 ICs. That had nothing to do with the issues that I was facing. Those issues are all around loading software. For example, if we take the original one and stick it into my supposedly working VIC-20, well, you can see it does boot to the cartridge. I did manage to get the firmware installed on that. Although if we do get the problem resolved, I will be updating the firmware on that and I'll show you that process. But if we dump back into BASIC, well, everything does appear to be working, doesn't it? There is 28,159 bytes free now. That is the maximum that the final expansion 3 will give us. The VIC-20 only supports a maximum of 32K anyway. But if I try to, say, run the FE3 diagnostics, which I have on the SD card in there, so let's load the directory of the SD card. That works okay. We can even list that directory, and what we want to do is load FE3 diag.program. If we then run that program, error. So what's all that about? Well, my initial thought was something wrong with this. I went fault finding, couldn't find anything wrong, so decided to build this one. Trying that again though with this cartridge. There's more on that SD card, as that is the one I am planning to use permanently with the expansion. Well, when I ran the program this time, that was weird. It appeared for a second, said an error, and then clear screen. What's that all about? And in fact, the VIC has crashed. Quick power cycle, trying that again. There's our errors again. So, something wrong with this expansion as well. I know I'm not the greatest person when it comes to assembling and programming these components here, but 2 for 2 with exactly the same fault and all brand new components. The other odd thing is that occasionally the SD to IEC itself just will not work. Let me see if I can force an example of that. And there's one of the read problems. I can list out the directory. If I try to run the software again though, illegal device number. So yeah, I was initially thinking there was something wrong with these. I was getting all sorts of problems. I have flashed the firmware on these I don't know how many times. The SD to IEC firmware and the final expansion firmware itself. Tried various different versions of it, and the problems just persist in one way or another. But after making a post about all this over on the VIC-20 denial forums, yeah, it seems that my beautiful example of a VC20 here, it seems it might have some sort of fault. Now my other VIC-20, which is boxed, it's in storage at the minute and it's just a bit buried to try and get out. But what I do have is this board. You haven't seen this yet. This came as spares along with the other machine that I'm trying to repair for the charity. But spoiler alert, this board works. Although granted it is missing a few bits. So let's take those few bits that are missing off my machine here, just because they are all in sockets. I need a VIA, the VIC itself and the CPU. We'll take those, put them in there and try these cartridges again. I will have to leave everything just sort of balancing there. Let's throw the switch. So final expansion has came up again. This board does seem to have quite bad jail bars. I think it might be a capacitor issue. Although they've just cleared up. Obviously because I just spoke about it. But yeah, jail bars and the screen is a bit dull. Probably wants a recap. But oh, and there's the screen just came up as soon as I mentioned that as well. But that's not the purpose of what we're talking about here. So let's try and load the contents of that SD card again. We can list said contents and let's try and run the diagnostic suite. This time it runs fine. Everything passes okay. Let's try the other one. So cartridge comes up again okay, but let's drop back into basic and run the diagnostic again. And yeah, that cartridge passes as well. So something obviously wrong with my other VIC-20. It's just a shame it took me all day yesterday to 3 AM last night trying to figure that out. Anybody got any ideas what could be wrong with this? One thing I did try quickly was swapping the two VIAs around, because if that VIA was bad, well, the machine would have difficulties reading from the serial port. But no, swapping them around didn't make any difference. I'm wondering if it could be UB4 here, which is a 74LSO6, as it is involved in the serial port side of things as well. Or could it be something else? I unfortunately don't really have the time today to continue diagnosing this. So I think to finish off this video, because I am conscious that it is getting long enough, I think what we'll do is just push ahead with this board. But to finish off this video, how about we now update the firmware on this to the latest version. Now what I have on there, version 0.29, that is the latest official version, but there is an unofficial version referred to as the Ultimate expansion. It just fixes a couple of little bugs and speeds things up for us. So we'll jump onto the PC quickly. These are the files associated with the Ultimate expansion. So all we need to do is take the PAL firmware bin file and we're going to rename that FE3 firmware, and we'll send that to our SD card. The first time that you're setting up your Final Expansion 3, all you need to do is put the SD to IEC binary on the SD card. And I'll just show you the one that I used. It was this one here, ending in LARSPM2184. That matches the Atmega. So you just put that on the root of the SD card. The SD to IEC in here checks for an updated firmware every time it's powered on. If it finds one that's more up to date than the code in the Atmega, it updates it. Fully automated process, there's nothing there that you have to do. When it is doing that, you'll see the green LED flash. And to initially set up the Final Expansion itself, well, you need to use the official firmware for that. And like I did when I ran the FE3 diag program, all you're doing is running the FE3 flash program. And so long as you have that file along with the firmware file on the root of your SD card, yeah, it will flash the FE3's firmware. Once that's done, reset and it boots to that blue menu. But just as well, I did pull that up on the PC there, because that is how we need the firmware file to be presented. FE3 firmware, we don't want that .bin on the end of it. So stick this SD card in here. Power up and let's update our expansion. From the Final Expansion menu, we do that in FE3 Utilities, so F6, and it's just as simple as Flash Firmware. F2. Automatically finds the file, and there it goes. And that's it. We're now on version 1.4, and things are meant to happen a bit quicker now, including the drop out to basic, so let's just try that. Yeah, that is instant now, whereas before there was a slight delay. So let's go back to this SD card. This one has some software on it, and let's have a play with the Final Expansion. You can hot swap these SD cards, just so long as it's obviously not trying to access it. And we can hard reset the machine by pressing the black button on the side of the expansion. So we have a RAM manager, F1. And in here we can configure the amount of RAM that this is going to add to our VIC. Out of the box, it is pre-configured just to add all of it, giving us a total of 28,159. But you can limit it there, as you can see, to an additional 3, 8, 16. I'm not sure what the difference is between adding the 24 or the 24 plus 3K. Maybe if anyone knows, you'd let me know. But for now, as far as I'm concerned, F7, let's have all RAM. So the next option then, disk loader. That will read out the contents of the SD card. Well, sort of. The way this works is that it has loader files in the root and on each directory that is set up on that SD card. I've just downloaded a pre-configured image and just stuck everything on the one card. It is only a couple of 100 megabytes and has quite a bit in it. But you just can't stick any files you want on your SD card. This menu system here won't pick them up. You need to create a loader file, and the details of how to do that are all contained within the FE3's manual. I am not too worried about that at the minute though, because as I said, there are hundreds of games and demos just with that pre-configured image for the SD card. So we can, for example, take a demo. You know me, I love a good demo scene production. And I don't know, how about this one? $8 math. That's pretty cool. Little Nintendo inspired introduction. And away it goes with some very funky music. Pretty cool effects for the VIC-20. When you're finished with it then, just reset. We're back to the menu. The cart loader on here under F5. Well, this is for loading software directly off the flash memory on the FE3. But we first of all need to load software into that flash memory. You have 512K to play with. And the whole idea being that you put your favorite games or demos or whatever software in there, and it makes them easily accessible to you without having to worry about SD cards. So there's nothing in there at the minute, but we can put something in there, and you do that within the FE3 utilities, which is F6. And we want to flash a program. This then gives us the same menu as before. Let's take a game this time. How about Panic Man? I would assume that's some sort of Pac-Man clone. So all we do is select that. That will write that to the flash RAM. That's it done. We can then go out of this, F8 to go back to the main menu, F8 again. And if we go to the cart loader now, there it is, Panic Man. We can load it directly off the flash memory on this cartridge. And yes, it is indeed a Pac-Man clone. You know what, it actually plays really well. I'm in trouble. Very nearly did it, although it went a bit of a roundabout way. There we are. Level 1 complete. I just want to see if it has the animation after level 2. No, doesn't seem to. Or is the animation after level 3? Does it have an animation now? No, it doesn't. Okay. The help menu, well, that just has a list of some of the commands that you can run on this. But to be honest, I think you would be best with the manual beside you if you wanted to get into this in any great depth. And I will print off and include a full copy of the manual with this one that's going to the charity auction. But to be honest with you, I think most people will just use this for playing games or running demos. They'll use it as a flash card with a memory expansion built into it. That's sort of the reason I wanted it. It doesn't work exactly the way I thought. I didn't appreciate that you need to create those loader files. And it does look to be fairly complex, to be honest with you. I had a quick flick through the manual looking at it. But I suppose that's only if you want to use this menu system. You can drop into BASIC and just load files manually off the SD card, although you need those loader files to be able to add software to the flash ROM that's on here. In some ways, it almost makes me think that this thing is too complex, maybe in particular for the casual user, i.e. me. But as I said, within that loader files that are there, within the software that is there on that predefined package, well, I would say there's enough here to keep me going for the foreseeable. There's plenty of demos, and I do love a good demo. And how about we pick, oh dear, should we pick Nyan Cat? Let's go with Nyan Cat. Come on, how bad could it be? Oh yeah, it's just awesome, isn't it? Okay, it is a very basic demo, of course it is. But you need to remember what this machine is. It's a 1982 computer with only 5K of memory on board. We have expanded that RAM, but you know, it's still a 1982 computer. And for full screen graphics like that, with the sound playing, and as cheesy and as colourful as it is, yeah, it's just awesome. So this one will be updated to the latest version of that software as well, and it's that one that will go to the charity auction. That was quite the stressful build, and all caused by those problems with my VIC-20 board. So if anyone has any ideas what could be wrong with that board, please let me know. Considering that the faults seem to come when trying to run basic commands, I'm actually wondering if it could be something wrong with the basic ROM, although that ROM isn't in a socket in my board, so we would need to get the Moo gun out to test that theory, and just at the minute I unfortunately don't have the time to do that because I still need to get the other VIC-20 board working, the one that is going to the charity auction. You'll hopefully see that in the next video, which should be out on the 13th. The auction itself will be going live on the 12th, and all links to that will be added to this video's description, the next video's description, and there's a couple of second channel videos related to all of this as well. So make sure you keep an eye out for all of that. Why not hit subscribe so that you don't miss the next videos, and if you enjoyed this video, please leave a thumbs up. But that's going to be it for now. Thank you for watching, and I'll see you next time.